Right, so what we're going to achieve today, we have looked at this before. I wanted you to use your calculators, obviously a bit of practice in this. We're going to look at the graphs of the trig functions. You know what I mean by trig functions? Sine, cosine, tangent. Okay? We're going to really just look at today the sine and cosine ones because they're the main ones you have to be able to deal with. Right, so the general form of a trig function would be y equals, or fx equals, a sine or cosine, do a sine, b x, so I'll put that in brackets, plus c, which is all you're going to need to have to worry about. So a couple of things that you're going to have to be able to do. First off is maybe sketch the curve, right, given a function, or you're going to be able to do that, you're going to have to be able to identify all the components of the curve from the function. So you need to know what A, B and C do. And then of course, if you can do that, you'll be able to do the other one, which is you look at the curve and write the function. Now that gets a little bit different in the fact that what they ask you to do is look at a function that is applied to a real situation. So instead of x, it'll be t for time, and it'll be tide height or something else, okay, that is modelled by a circular function. Right? Can you, any ideas why? Can you remember why trig function is also called a circular function? Because of the unit circle. Do you remember unit circle values? Anyone think I could throw one at them and they remember what it was? Sine of 30?
Is it square root 3 divided by 2?
No, it's not, I'm afraid.
1 over
1 over
root 3 over 1. No.
Sine
3 over 1 is root 3.
Sine of 30. A half. Would you say? Cos of 60.
Root 3 over
Half.
exactly.
Sine of 30, cos of 60. Yeah, equivalent. Tan of 60. 1.
No, 3. 3.
Square root of 3.
0.
3.
Tan of 60.
1 over root 3.
1 over square root of 2.
Root 3 over
You're
2.
just guessing now, aren't you?
Yeah, 10.
Root 3. Well, one of you's got it down.
Yeah.
Can you not? Do you not visualise the circle in your head? The triangles in your head. Right? They're triangles to enable you to work those things out. I'll just come back to this a second. I was kind of hoping that you'd remember that they come from the triangles. Right? One of them, the 30 and 60, comes from the fact that we do an equilateral triangle cut in half. Okay? And then this length is 2. This length would be 2, but if I cut it in half it becomes 1. This angle is 60, this angle is 30. This side, you either have to work it out or you visualise and go, well, that's the one that's root 3. Do you remember how to remember it's root 3? Yeah. So, for me, what I can't do just that. So I memorise or I visualise in my head just this. I remember 30 at the top. I remember 60 and I remember the root 3 and 2. And then, so sine of 30, opposite over hypotenuse. Cos of 60, adjacent over hypotenuse. Tan of 60, opposite over adjacent. Tan of 30, 1 over root 3. Okay, now we've got 30 and 60, but there is another triangle, which is which one? What does it look like?
45 degrees.
So 45, and how do you remember the triangle? What kind of triangle is it? It's what? Isosceles, what dimensions? So right angle on this length is a what and a what on the triangle? Should I say that again? 1 and 1, yeah. 1 and 1, which why we have 45 and 45. And then this length is a remember how to work it out?
Square root of 2.
Square root 2, yeah. Is there anyone that doesn't know where these numbers are coming from? Never seen them before in their life. Doesn't know. Okay, alright. So if I said sine of 45, 1 over root 2. Cos of 45,
Oh, that's
1 over root 2. Tan of 45, 1. Okay. So that one's nice and simple. Right. So that's those two triangles are for certain values. So, you know, sine of x equals something, cos of x equals something, and tan of x equals something. So that's where we've met them before. And then Nika's talked about the unit circle. Do you remember what the unit circle was about, Ivan?
It's to find the same values of, for example, sine 30. It's also the same as sine 100 and no 100.
Yeah. So if we go to sine of 30 there, what length is the sine of 30 of that? So it should be a triangle. Which side is the sine? Revision there, but obviously. So this point here has a coordinate based on this length and this length. So what's the coordinate of that point if we consider this to be 0, 0 in the middle? Yeah, so the coordinate here would be, for this one, cos 30, sine 30. Alright? So if we can remember what those values are, we get exact values. And if we keep going round the circle, we get to the equivalent point over here. But that angle is what angle? 150. Why is it 150?
Because it's 180 minus 30.
Yeah, because if we were to go all the way, it's that would be 30, but don't deal with that one. So this coordinate here would be
Negative cos 30.
negative cos of 30 and sine of 30 would, you know, we could use that, or cos of 150 sine 150. So why is it negative cos 30? Someone explain? Praxia? Yeah, so if we take that as 0, 0 in the middle, it's like having a set of axes. So if I draw a set of axes down the middle, right, so it's like if that side is positive cos, this side must be negative, the same value. Okay? So it's a quick recap, but things we have met this stuff before. Alright, so certain values. Anyway, back to what we want to sort out today, which we have done before. So that was all just why is it circular function, because it goes around the circle, keeps on going forever. So, does anyone remember what the A, the B and the C relate to on the curve? So the A is amplitude of the curve. The B is what you say? Right, so B is actually the number of waves in 360 degrees. And what we can say from that, which has come down here, is 360 divided by B is the period, so the length of the wave. Okay. And C is
y-intercept, where it crosses.
I'm going to say no, it does with this one, but it doesn't work with cosine. That's what he said. Okay, okay, but what do you mean by a shift? Because we've got to have a starting point to have a shift. So the plot, how would we go? Well, that graph, a shift from where? No, the plus C is not a left or right shift. No, it's not. Plus C, no, it's not up or down either. Oh, no, it's a shift up or down, but from what point?
0, 0. Origin?
No. What? A middle point or a middle line?
Oh.
Okay. Remember, a circular function goes up and down, above and below a line. Right? The reason why I say it's not the starting point is because sine and cosine don't start at the same point. And it also depends where you start from. Okay? But they do both go above and below a certain line. And this is the equation of the, so I would say the equation of the centre line. People call it the line of symmetry, but it's not a line of symmetry either. Alright? Now, the plus C, as Leah said, if you change the plus C, you will get a shift in the y direction, up or down. But it's like how much of a shift, so it's that line. Okay, so all this relates back to the basic. So how would you draw just sine of x and cosine of x? Do you remember the main points? So let's draw sine of x first. So what are the values? I put lines here for a reason. I'm going to use 90, 180, 270, 360. Minus 90, minus 180, minus 270, minus 360. And I'll put points here that are relevant. That should be on the line. What are those points going to be for sine and cosine? 1 and minus 1. Okay. How do we sketch this curve then? That's important. Is there anyone that thinks if I said now just sketch the curve of sine of x, you could not do it? Right, get on with it then. See what it looks like. So we're drawing just y equals sine of x. So what's the starting point? Tell you what, actually, here's the point. Let's work it out on our calculator, since we've got our calculators and I made a big fuss about you having them. So, you've got your calculator. Why don't we draw it on? So, on your calculator, what does your calculator need to be set to when we're doing this?
Degree.
Degrees. So make sure you press mode. Mine's on radians. So I'm going to go down. I'm going to make sure it's in degree mode. Yeah, degrees radian only matters with circular functions. Okay. We'll have a look why in a bit. What will your window need to be set to?
For x, negative 360 to 60.
Yeah, if we're going to do what I've done, negative 360 to 360. I've got minus 2 to 2, but actually it could be just as easy be negative, let's do 1.2 to 1.2, that would fill the screen nicely. Okay, and then put the equation in. I'm going to do, just press your sine button, sine of x. Press graph.
It's like a wave.
It is a wave, yeah. You all get the same thing? Okay, so where are these values? What's this value? The main points here, here,
0, 0.
here, here, here. So, we've got, let's just take this half, because it's obviously repeated. Where does it start, the sine curve? 0, 0. So I can start at 0, 0. Where is it meeting the net 0 the next time? 180, and then 360. So they're the important points to remember. Okay. And then where is it at its maximum and where is it at its minimum?
90 and 200.
So 90, it's nice because it's got lots of symmetry about this. Okay. So then we just have a nice curve. Now I think we've done this before. Try and make it a curve and not a couple of pyramids. I just messed that up. Try not to draw your curve like this. Because it is a curve and not straight lines. Alright? So yours is going to be better than mine. Right. And the other side? Same thing again. Minus 180, minus 360. But this time we've got to go down to a minimum at minus 90, back up to a maximum at 270. Okay. Alright, we'll do very quickly then what you have done before. So on your calculator, let's have a play with what happens if we put something in front of sine. So 2 sine x. So we think that's the amplitude. So the amplitude is what goes above and below the line. So I will need to change my window here if I know what I'm doing to what?
Y equals minus 2 and y equals 2.
So I'm going to do 2.2 just because it's gives me that bit of clearance at 2.2 graph. Hasn't changed. Oh yeah, there we go. Okay. So, if I were to do y equals 2 sine of x, obviously I need to go from 1, I need to go up to 2, and minus 1 down to minus 2, and then all these points are the same, but the maximum point has to shift up and down. Okay. And curve goes like that. That's a better one. Alright. So, any questions about amplitude? We're doing this very quickly, I'm aware. I'm kind of thinking we've done this before, so we're doing it quick. Any questions about that? Are you all happy? Well, let's take from this, if we know that A, amplitude is from the centre line up to the point, or down to the minimum. So it's from centre to max, so that distance there is A. Right. Okay, so what will happen, let's come back to B. what happens on my calculator if I do a plus C? So if I take my thing here, let's do 2x again, 2 sine x, let's do a plus 1. What's your prediction of what will happen?
All the points will, all the y points will shift up.
Yeah, so the x coordinates won't change, the y coordinates will move up 1. Okay, so that means my graph is going to, my first one still looks the same. My second one now goes off the screen. So, if you had to describe exactly what it was to someone of how to draw this now, so if I were to make a new set of axes, so here's my new axes, right. Okay. How would you tell them what to do to draw y equals 2 sine x plus 1? What would you say to them? How would you sketch that? Spherica, any idea? What would you tell someone? No? Have a guess.
I actually don't know.
You don't know. Anyone? People that haven't answered so many questions? Because I know these guys at the front know what they're doing now. Tim?
So number 2 is the amplitude of the wave, which
So
is the height,
2 is
the maximum and the minimum.
yeah, so 2 is the height, so that's to do with the maximum and minimum point. So would I say, Tim, that the maximum is at 2 and the minimum is at minus 2?
No, because the plus 1 at the end can shift the wave up or down.
Okay, so this, do you remember I said that the plus 1 was the equation of the centre line, so I have to actually, I'd do this with a dotted line if I were you. I would basically shift the centre line, or shift up from the axis, and I've got to mark where 90, 180, 270, 360 will be. Okay. I'm just going to drop this up. So doing y equals 2 sine. Right? So I'm only doing 1/2 of it at the moment. So what will the maximum value be? Valentina, do you know?
The maximum.
So the graph will go to a maximum, and what value maximum will that be? So the maximum was when it was 90 and it was at 2. So the maximum is going to stay at 90, but what will the maximum be? 4, you think? Why do you think 4?
Oh, is it still up to 2?
So the amplitude is still 2, but now I've got this plus 1. So where do you think the maximum will be?
I'm not really sure.
Not sure. Ella, do you know? No? Do you know what we mean by amplitude? So it's the distance from the centre point. So if we've got to go an amplitude of 2 from that central line, if the centre line is now at 1 and we've got to go a distance of 2, Alexander, the maximum will end up
3.
at 3. Okay, so this point, it was at 2, but if we shift the whole graph up 1, it will now go to 3, won't it? The question is, the minimum was at minus 2, does the minimum go to minus 3?
No.
Where does the minimum go to? Minus 1, because everything shifts up. So we go to minus 1. So the minimum values will be 270 still, and the zeros are no longer on the axis, they're on the new values centre line. So 0 there, sorry, there and there. So now my curve looks like this. Alright, so the amplitude is still that value of 2, but it starts at 1, therefore goes to 3. Okay, so that's the A value. Alright, and this 1 is the C value that we put in. Right, so what does sticking something in the X in there then? So tell me what I've done if I insert 0.5 in front of the X.
Isn't it's gonna be like only one? It's gonna be like a half of a wave in 360 degrees.
Yeah. Now I didn't change my sense line, so it's still off the screen. Okay. But if I did y equals 2 sine like half x plus 1. So I'm not changing the amplitude. I'm not changing the equation of the centre line. What I'm now saying is there's half a wave in 360. So that will look like, well, it's going to shift which points? It's going to shift all my intercepts. So this maximum, the gravity needs to now go out.
I'm sorry, I was gonna say that it goes to 180.
So the maximum goes to 180, yeah. So I put that on that point there. And the 0 starts still at the same place, but the end of the curve finishes there. So in 360, the curve is going to look like that. So this is the question that links with this then. If that's B, so B equals a half, what is the period of this wave? 720, okay? Right? Because we do 360 divided by whatever B is, so divided by half is 720. Okay. Right. Same things all apply with cosine. Although cosine, what's different about cosine?
It starts at 1.
It starts at 1. Is there a curve that starts at -1? No. Negative cos starts at negative. Okay. And what do you think negative sine will look like?
Flip.
Yeah, it's a flip. If you do negative cos, negative sine, it goes, instead of going sine, instead of going up to start with, it will go down to start with. Instead of cos coming down, it will go up to start with. So you should have a practice of that. Right, in the last minute, these rules for A, B and C, the coefficients of the circular function, always apply. It's always 360 degrees divided by B, right? The period, whatever the period is always 360 divided by B. Just because in an applied situation, the time might be 1.6 hours. Do you think that has any impact on 360 divided by? You think changing x to t for time, do you think it changes the 360 thing? No, it doesn't. That's where people get confused. So the wave, even though it's 1.6 hours, you still apply these exact same rules. So next time what I'll try and do is we'll find some questions that are applied, put them in context, looking at the different numbers, and you'll be able to practice on them. So make sure before that time, you're 100% certain with graphing it on your calculator, being able to sketch them, and also looking at the sketch and saying what curve is. Now I'll have a little bit of a test of you next time. I'll give you a curve and ask you what the function is. Okay.